Hello and welcome. Today, we are going to crack the code on one of the most fundamental things in all of math, equations. Now, I know they can look a little tricky sometimes, but I promise, by the end of this, you'll see they're really just puzzles with one very, very important rule.
Yeah, you ever see something like this pop up on a page and just your brain kind of freezes for a second? With all the letters and the fractions, it's totally normal to think, whoa, where do I even begin with that?
Well, here's the secret. You are definitely not alone in feeling that way. But the good news is that every single equation, no matter how wild it looks, is just a logic puzzle. And you know what? Like any good puzzle, there's a key. A single, simple, golden rule that unlocks the whole thing. So let's find it together.
All right, so first things first, to get started, let's make sure we're all on the same page. What exactly is an equation, anyway? Okay, let's clear up something that trips a lot of people up. What's the difference between an expression and an equation? Well, think of it this way. An expression, like 3x minus 2, it's like a phrase. It's just kind of hanging out. But an equation, 3x minus 2 equals 7, now that's a full sentence. It's making a claim. It's saying that whatever is on the left side has the exact same value as what's on the right side. And that really gets to the heart of it. An equation is simply a statement that two things are equal. I mean, it's right there in the name. The word equation literally comes from the word equal. That equal sign is the star of the show. It's a promise that both sides are perfectly balanced. So what about that letter, the x or the y? That's our variable. And really, you should just think of it as a mystery number. It's the unknown piece of the puzzle we're trying to find. The whole point of solving an equation is to figure out the one specific value for that variable that makes the whole statement true. Okay, now for the most important part. I'm talking about the one concept that's going to let you solve pretty much any equation you ever come across. I like to call it the golden rule of balance. And here it is. It's so simple. Just imagine an equation is like one of those old school balancing scales. If you put a 5-pound weight on the left side, it's gonna tip, right? To get it back in balance, you have to put the exact same 5-pound weight on the right side. It works for everything, adding, subtracting, multiplying, dividing. You just have to keep it balanced always. Let's see this rule in action with a simple one. X minus 2 equals 7. So our goal is to get x all by itself. To get rid of that minus 2, we have to do the opposite, which is add 2. But, and here's the golden rule, if we add 2 to the left side, we absolutely must add 2 to the right side to keep things balanced. On the left, the minus 2 and plus 2 cancel each other out, leaving just x. And on the right, 7 plus 2 is 9. And just like that, there's our answer. X equals 9. Okay, that was a pretty good warm-up, right? Now let's build on that. We'll try a slightly tougher problem to really get the hang of this. So, take a look at this one. 17p minus 2 equals 49. It's the same rules, we just have one extra little step. So what do you think? What's the very first move? Remember, our goal is to get p all alone, so we need to start peeling away the other numbers, kind of like peeling an onion, one layer at a time. If you were thinking, get rid of that minus 2 first, you are absolutely right. We add 2 to both sides of the scale, which leaves us with 17p equals 51. Okay, now p is being multiplied by 17. To undo that, we do the opposite. We divide. And to keep it balanced, we divide both sides by 17. And that gives us our final solution, p equals 3. See? It's just a couple of simple, balanced steps. Awesome. Now that we've got the basics down pat, let's use our golden rule on problems that look a little more intimidating, specifically the ones that have those pesky brackets. So, what do we do with an equation like this? Now we've got variables on both sides, and they're kind of trapped inside these parentheses. It looks a little messy, I know, but the process, the core idea is exactly the same. We just have a new first step. So the first thing you want to do anytime you see brackets like this is to expand them. It's also called the distributive property. You just multiply the number on the outside by each thing on the inside. So 5 times x is 5x, and 5 times negative 3 is negative 15. On the other side, 3 times x is 3x, and 3 times 2 is 6. And look at that! Now we have an equation that looks way more familiar. And from here, we just use the same logic. We want to get all the regular numbers together, so let's add 15 to both sides. That gives us 5x equals 3x plus 21. Next, let's get the x terms together. We can subtract 3x from both sides, which leaves 2x equals 21.
And the very last step is to get x completely alone, so we divide both sides by 2. Our answer is x equals 21 over 2.
Okay, so this is all great for math class, but why does any of this actually matter? Well, it turns out that equations are basically the language we use to solve all sorts of puzzles in real life. Take this problem, for example. This isn't just a bunch of numbers on a page. This is a real question. A cricket player has 2 scores, and they want to know what they need in their last match to hit a specific average. This is the perfect job for an equation.
The first skill here is just turning the words into math. The thing we don't know, the runs in that third match, that's our mystery number, so let's call it x. We know that an average is just the total runs divided by the number of matches. So we just plug in all the numbers we do know, and boom, we've built ourselves an equation.
And once you have that equation, you just use the same golden rule of balance we've been using all along. You multiply both sides by 3, you subtract the other scores, and you solve for x. And the answer? He needs to score 253 runs. And just like that, you used a little algebra to solve a totally practical, real-world problem.
So let's just quickly run through the key things to remember. An equation is a balanced scale. That equals sign is the middle, the pivot point. The one rule you can never, ever break is that whatever you do to one side, you have to do to the other. And your goal is always, always the same. Get that variable all by itself.
So now you have the key. The next time you're trying to figure out a budget, or maybe calculate how long a trip is going to take, or even just split a dinner bill fairly with friends, think about it. You are probably just one simple equation away from finding the answer. What other puzzles in your life could you solve now?